Department of Energy has completed a major project to safely stabilize radioactive waste materials at the Niagara Falls Storage Site in western New York. The 5-year project included the cleanup of the 191-acre DOE-owned site and more than 24 other properties in the area. About 250,000 cubic yards of contaminated material is now sealed underground in a 10-acre engineered containment structure. Radiation levels on and around the site are well within federal standards. The Niagara Falls Storage Site is in the town of Lewiston, about 10 miles north of Niagara Falls. Its present 191 acres is the remaining part of approximately 1,500 acres acquired by the Atomic Energy Commission in the 1940s from the Army's Lake Ontario Ordnance Works. Some of the materials at this site came from the Manhattan Project, America's secret World War II experiment that resulted in the first atomic bomb. The AEC and its successors have also used the site to store various residues from uranium processing operations in the Buffalo area and elsewhere. Some of the residues were stored in concrete buildings, such as this 165-foot tower. Other materials, known as R10 residues, were stored on the ground in the open. Over time, some of these residues from the R10 area had eroded into the central drainage ditch and then off-site, accounting for the majority of the nearby property contamination. In 1982, remedial action was started both at the site and on vicinity properties under 2 DOE programs, the formerly utilized Sites Remedial Action Program and the Surplus Facilities Management Program. Before remedial action started, materials were continuing to erode off-site, and at some locations near the site boundary, the concentration of radioactive radon gas exceeded the federal standard. The priorities were clear. Stabilize the R10 residues to prevent further off-site erosion, and upgrade and seal 2 residue storage buildings, the source of the radon gas. Work began by clearing the R10 area and consolidating the contaminated materials and soil. A clay dike and cutoff wall were then constructed around the pile. The 2 buildings containing radioactive residues were sealed with layers of clay and synthetic fabric. This action reduced radon emissions to essentially normal background levels. The development of the waste containment area continued as the primary activity during 1983. The dike and cutoff wall were extended southward to enclose additional buildings. Preparations were also made to use this structure, Building 411, for storage of residues to be removed from the concrete tower, located almost a mile away on the east end of the site. Also in 1983, cleanup began on both the west and central drainage ditches. By the end of the year, about 54,000 cubic yards of contaminated material had been placed in the waste containment area. By far the most physically difficult task undertaken at NFSS was the removal of the K65 residues from the concrete tower, Building 434, a 165-foot silo-shaped structure that was a landmark in the Lewiston area. This work began in 1984. About 4,000 cubic yards of K65 residues had been placed in this structure during the early 1950s. Most of it was in the bottom of the tower, but a portion had also been put in a separate upper section. The residues were inaccessible and generated large quantities of radon gas, requiring anyone within a few feet of the tower to be respirator equipped and dressed in protective clothing. The residues were removed using a hydraulic mining unit that formed a slurry mixture of residues and water. The slurry was then pumped through a 4-inch steel pipeline to Building 411. After the residues settled out of the slurry in Building 411, the water was pumped back to a holding pond next to the tower to be recycled. The mining unit was suspended in the center of the tower by a crane and lowered as the work progressed. The unit was remotely controlled using a TV camera installed inside the tower to guide operations. Another major activity in 1984 was completing the cleanup in the central drainage ditch, which runs north from the site and then northwest into 4 Mile Creek. By the time the project was finished, about 4 miles of the ditch had been cleaned and the contaminated soil taken to the waste containment area. In 1985, another milestone was reached when the last of the K65 residues were removed from the tower by mechanical means, and the building was demolished. Its rubble and the contaminated soil surrounding the building were removed to the waste containment area. Also in '85, the major portion of the interim cap over the containment area was completed, and the K65 residues in Building 411 were dewatered, allowing these residues to be sealed in place before the building was buried as part of the waste containment area. In 1986, the last of the total of about 25 contaminated off-site properties were cleaned. These included properties north of the site along the central drainage ditch, areas on Model City Road south of the site, small areas along Pletcher Road, and portions of the modern landfill property east of the site. The final portion of the interim cap was also completed in 1986, and turf establishment and other maintenance activities continued on into 1987. During the course of the remedial action at NFSS, approximately 14 million gallons of radioactively and chemically contaminated water had accumulated from construction runoff, equipment decontamination, the K65 residues transfer, and other operations. To remove contaminants, this water was treated in large batches, such as the pond shown here. After being cleaned to meet stringent standards set by the New York Department of Environmental Conservation, it was then released to the central drainage ditch. The completed waste containment facility utilizes a naturally occurring underlying clay layer as its bottom. The sides are formed by cut-off walls keyed into this clay layer and topped with clay dikes. The dike and cut-off wall function as a continuous barrier to prevent radionuclide migration to both groundwater and surface water. The containment facility is covered with a cap designed to minimize water infiltration, radon emanation, erosion, and frost heave damage. A 3-foot thick layer of clay is the main component of the cap. 18 inches of topsoil covers the clay, followed by a final turf cover. The cap is sloped to enhance natural drainage away from the storage facility. The interim cap has a design life of 25 to 50 years and can be upgraded to a design life of 200 to 1,000 years by adding a thicker clay layer along with a layer of riprap to serve as an intrusion barrier. Other barriers may be required based on EPA guidance yet to be developed. With the waste containment area now closed, both surface and subsurface monitoring will be performed to ensure that if any undesirable trends in the physical condition of the facility are detected, timely corrective actions can be taken. One unusual feature of this monitoring system is a series of pressure-sensitive sensors that have been placed in the waste containment structure. 2 types of devices have been installed. Used in tunnel and dam construction, they're known as vibrating wire pressure transducers and pneumatic pressure transducers. Here's a drilling rig used for installation of these monitors. The system transmits data via cables to a recording device in a nearby building where the data is regularly analyzed to confirm that the cap is performing as designed. Other monitoring techniques being used include topographic surveys, walkover inspections, aerial photography, and monitoring wells. In addition to the waste containment area, the DOE is continuing to monitor the area around NFSS to ensure that all environmental standards are met. This includes monitoring air, surface water, groundwater, and direct radiation. Radiation is a natural part of our environment. It's all around us, all the time. It comes from outer space in the form of cosmic radiation, and it comes from naturally occurring radioactive elements in the rocks, soil, and water of the Earth itself. This natural radioactivity is called background radiation, and it will be different from place to place. On Goat Island at the brink of Niagara Falls, natural background radiation can range from 7 to 10,000 counts per minute, depending on exact location. Here, a highly sensitive radiation meter detects a reading of just under 8,000. Moving a few yards away can result in a different reading, as much as 1,000 counts up or down. If the same meter were taken to Denver, Colorado, it would measure an average of almost 3 times that amount, more than 20,000 counts per minute. At Denver's mile-high elevation, cosmic radiation is greater because there is less atmosphere to filter out the cosmic rays. Taking the meter to a different location in the Niagara area, the readout shows just over 8,000 counts per minute, essentially the same as at the falls. The significant thing about this comparison is that this particular location happens to be directly on top of the waste containment area. Completion of this project is a major milestone in the Department of Energy's program to safely stabilize radioactive residues resulting from the nation's early research and development of nuclear energy, and through future monitoring and maintenance at the Niagara Falls Storage Site. The DOE will continue to protect the health and safety of the public.